Hi, and welcome to this new lesson. In this lesson, we're going to explore one of the most fundamental and visually insightful concepts in thermodynamics, the saturation curve, and how we can use the case study tool in Aspen HYSYS to plot and analyze it. We will use Aspen HYSYS to generate a temperature-pressure diagram, TP diagram for water, focusing on the curve that separates the liquid and vapor phases, known as the saturation curve. This curve extends from the triple point of water all the way up to its critical point. You're probably already familiar with this diagram from your thermodynamics courses. For example, at 100 degrees Celsius, if the pressure is exactly 1 atmosphere, water is at its saturation condition, it's right on the saturation line. If the pressure is below 1 atmosphere, at 100 degrees Celsius, water exists in the vapor region, which is below the saturation line in the diagram. And if the pressure is above 1 atmosphere, it is in the liquid region above the line. In this lesson, we aim to recreate the saturation line for water from around 0.01 degrees Celsius, the triple point, up to 374 degrees Celsius, the critical point, using Aspen HYSYS. If you have just one temperature, it's easy to find the corresponding saturation pressure in HYSYS. Simply set the vapor fraction to 1, and HYSYS will calculate the saturation pressure for you. But what if you want to calculate this for many temperatures, say from 0.01 degrees Celsius up to 374 degrees Celsius in 5-degree intervals? That's where the case study tool becomes very useful. The case study feature in HYSYS allows you to systematically vary one or more independent variables and observe how one or more dependent variables respond. It's not just useful for plotting saturation curves, it's also commonly used for optimization studies, sensitivity analysis, and finding operating limits. Now let's complete the lesson on how to plot the saturation pressure versus temperature curve for water using the case study tool in Aspen HYSYS. Just like before, I select water as the component and choose the ASME steam fluid package, which is highly recommended when dealing with steam or water phase calculations. I then enter the simulation environment. I add a new material stream to the flowsheet and name it Stream 1. In the Workbook, Composition tab, I set the water fraction to 1 and click OK. Then, in the Conditions tab, I set the vapor phase fraction to 0. This represents the saturated liquid condition, meaning water is just about to boil. This corresponds to a point on the saturation curve we're interested in. For the temperature, I enter an example value, say 100 degrees Celsius. As you can see, HYSYS calculates the corresponding saturation pressure automatically, which is 101.3 kilopascals or 1 atmosphere, matching thermodynamic tables. Now, we want to plot the saturation pressure curve for a wide range of temperatures. To do this, click on the Case Studies icon from the toolbar, or access it from the left-hand panel under Tools. Click Add to create a new case study. Under the independent variable, click on Find Variable, then select Stream 1. Search and select Temperature. This is because we want to vary the temperature. Under the dependent variable, click Find Variable again. Select Stream 1. This time, search and select Pressure, because we want to see how pressure changes with temperature along the saturation line. In the Case Study Setup tab, the current value of temperature is shown, which is 100 degrees Celsius in our example. Now, set up the range for temperature. Start value, 1 degree Celsius, because triple point is at 0.01 degrees Celsius. End value, 374 degrees Celsius, near the critical point of water. Step size, 5 degrees Celsius. which gives us 75 calculation steps. Click Run to start the simulation. Once the calculation is done, in the results table, you can see how saturation pressure varies with temperature. You can select the cells and copy them to Excel or another spreadsheet tool, just like I'm doing here on the screen. Or simply click the Send to Excel button. By default, HYSYS shows all the cases in the table, both successful and failed. To filter the list, click on the drop-down menu at the top of the table. You'll see three options: All, Succeeded, and Failed. I'll go ahead and select Failed. Now you can clearly see the rows that failed, including the input value, like temperature, where the failure happened. This allows you to investigate the problem point by point, or simply ignore it if it's not critical to your analysis. Now, as you can see, most of the points in our case study have been calculated successfully. However, in one specific case at 251 degrees Celsius, the software failed to compute the result. This kind of issue is not uncommon in Aspen HYSYS when using the case study tool, especially when dealing with complex property packages like ASME Steam. These failures typically occur due to numerical convergence issues, where the solver is unable to calculate the dependent variable, in our case the pressure, based on the specified conditions. But don't worry, this is not a critical error and does not affect the overall results or trend of your saturation curve. Next, go to the Plots tab. Here you can easily visualize the curve of saturation pressure versus temperature. This is effectively the saturation line in a pressure-temperature PT diagram, which divides the liquid and vapor regions.